Good evening folks, this is going to be a super quick video on this component here, which is a resettable bimetallic thermostat switch. And essentially what it is a switch that is operated by heat. And you get these in various things like cookers. You know, when you turn your cooker on, you set it to 200 degrees. When it gets to temperature, it turns off, doesn't it? That's the same kind of thing, although this is a manually reset one. Obviously your cooker one will come on and off as required. But yeah, this is let's say it's bimetallic, and it's resettable. And this came out a product which obviously has a heating element in it, and once it had got up to temperature, which in this instance was about 96 degrees, it would turn off, and then you would have to reset it to use it again. So I thought it'd be interesting to show you inside this and show you how it actually functions. So on the bottom we've got this aluminium can, and then inside we've got this metal disc which appears to be steel, but if we turn it over you'll see it's a sort of brass, tarnished brass on the other side, and that is the bimetallic element of the thermostat. And what that essentially does is, to explain what bimetallic means, is bimetallic, bi meaning two, metallic obviously metal, and it's two different types of metal which are joined together, you know, face to face, completely joined together, giving you a laminate of in this case steel and brass. And brass, when heated, expands far faster than steel, and it might be difficult to see, well, it might not be. You can see that the brass side hopefully is concave, and the steel side is got a slight dome on it. And what happens in this sort of application is when it heats up, and if you remember the way this was put in, the steel was shown, when it heats up, let's say the brass expands and goes out the way, and this dome will actually pop to the other side. I can demonstrate this just by using my finger. You hear it clicking? And that just pops out. It's a bit like, if you remember, I was born in the late 70s, but I remember as a kid in the 80s and early 90s, you used to get those little rubber sort of half balls that you turned inside out, sat on the ground, and they used to, after a few seconds, pop out and then they would jump up. And it's kind of a very similar thing, if that makes sense. I know it's a really bad analogy, but that's the only way I can really think to explain it. But what happens is when that dome does pop through to the other side, it depresses this little white pin, which you can probably just see there, and that's guided or you know, held in this sort of black plastic guide, and it then depresses that contact, thus breaking the circuit. And once you've unplugged it and let it cool down for a few seconds, you can then reset it by just, you know, pressing that red button, and all that does is pushes the contact, which pushes the white pin, which pushes the centre of the disc, bending the disc through to the other side, and then making the contact closed again. So I will just quickly actually show you in operation, not an operation, but I'll actually show you the bimetallic disc functioning. So if I just hold it like so, and you can see that is the concave side, and if I just use a bog standard lighter here, and if I just bring it in, you shall hopefully be able to see it changing. Yep, so you just see it went dark because it's not reflecting the light as well now. And if I just cool that down and then press that in the middle, exactly the same as it would be in there, that red button be depressed would push that down. And we'll do it again at another angle so you can see it, and you should see it bending towards my left hand here. So if you just watch this, yeah, do you see it moving towards the flame? We'll do it one last time. This time we shall use the pliers for reference. You can see that the disc is perfectly in line with the slight gap in between the two parts of the pliers. And now you can see now that it is bent over to the left. And that is a bimetallic thermostat. And Chris's rubbish fact of the day, or it might not be rubbish, it might come up in a pub quiz, I don't know. If you win anything, I'll take 20%. Only joking. But yeah, the opposite of a bimetallic, the operation of this is comes from or you know it from a term as us Brits use quite a lot when it's really cold. You'll hear, I mean, I'm sure you've heard people saying, God, it's so cold it'd freeze the balls off a brass monkey. And if you've ever wondered where that term came from, it's an old Royal Naval term. Back in the day, on the old warships, where we had cannons and cannonballs rather than, missile systems and, phalanx guns and all that good stuff. Yeah, we had cannons, and for those sailors that are watching, you'll know that on a ship everything is generally brass, because brass doesn't corrode as much in the salty water and salty sea air. So the brass monkey was basically a little frame on the deck of the ship for holding cannonballs. So obviously they wouldn't have cannonballs stacked up on there when they were at sea, but when it came to, right, we're going to have a battle, they'd bring up the cannonballs from the lower decks, the steel cannonballs, and stack them in the brass monkey. And in battles, when it's in really cold weather, talking Arctic and stuff like that, the brass monkey, the brass frame on the deck, would actually shrink because it was so cold, and thus the balls would fall off, hence freeze the balls off a brass monkey. So when it's heated, brass expands quicker than steel, but when it's cooled, it contracts faster than steel. So there you go, that's the difference. Anyway, I thought that might be interesting for you. Yeah, like say there's thermostats in your cooker, your kettle, your car, absolutely loads of things have got a thermostat of some form. And yeah, I just thought it'd be interesting to show you how one functions. Anyway guys, hope you enjoyed that. If you did, and if you learned something, give me the thumbs up. And please subscribe if you don't mind. And I'll see you soon for another video. Take care, all the best.